Welcome. This question is based on stoichiometry and the Moore concept, and it reads, what mass of sodium carbonate is required to make a 250 cubic centimeter solution whose concentration is 0.3 molar? Then we have those four options. Well, to find the answer to this question, the formula you use is M is equal to N times mm. Well, m is standing for mass, which we are looking for, and then n is number of moles. Number of moles. mm is molar mass. So then to answer this question, you need to find out the number of moles and the molar mass. When you look at the question, we've not been given the number of moles, nor have we been given the molar mass, but we have been given information to help us find those two. So then, let us start with number of moles. Now, to find number of moles, there is this formula. Number of moles is equal to mass over molar mass, or number of moles is equal to molarity, which is concentration, times volume here. Okay, so that is volume, that's V, then molarity or concentration. So then the formula you use depends on the information given in the question. So in the question we have volume and concentration. So we'll use this formula. And by the way, we can't use this one because we don't have mass. It's what we are looking for. So let's find the number of moles. Number of moles is equal to concentration or molarity times volume. What is our molarity? It is 0.3. What about our volume? It is 250 cubic centimeters. On volume, the unit must be cubic decimeter. So it must be in decimeter cubic, not in centimeter cubic. So if it's not in decimeter cubic, change it. So to do so, you are going to say the 250 that you've been given, or the volume you have, divide it by 1000, because 1000 cubic centimeters make up 1 cubic decimeter. So to change, you divide by 1000. When you divide, what you get is 0.250, which is negligible, then cubic decimeter here. So this is the volume we'll use, not the 250. Okay. So therefore, our molarity times 0.250. Therefore, number of moles is equal to, when we multiply these, we get 0.075 moles. So we have found the number of moles here. Okay. What remains is to find the molar mass. Now, molar mass, the way we find it is we just add the mass numbers of each atom. All right. When you go on the periodic table, we have these atoms. We have sodium, we have carbon, and oxygen. So sodium, you are going to find it as 23 on top. Carbon, you find it as 12. And then oxygen has 16. So the numbers on top are the ones you add to get the mass, the molar mass. However, we are going to say sodium, carbon, and oxygen here. Now, the mass number of sodium is 23. Now, you also look at the number of atoms. How many atoms of sodium? 2. So we multiply this mass number by the number of atoms, 2, which is 46. What about carbon? Well, the mass number of carbon is 12. and it only has one atom here, times 1 it's still 12. Oxygen, the mass number 16 multiplied by 3, which is the number of atoms here, 3, gives us 48. Then we just add these. Therefore, when we add them, we get 106. So then we have found the molar mass as well as the number of moles. Therefore, we simply are going to say mass therefore is 0.075, our number of moles, times our molar mass 106. When we multiply these numbers, we get 7.95 grams. That is our answer. Therefore, the answer here was B. To summarize, you have to know the number of moles and the molar mass. To find the number of moles, we use this formula. To find the molar mass, just look for the numbers on top of the atom that are in the compound. Then you add the mass numbers. You can find them on the periodic table. The numbers on top, just add them. However, you pay attention to the number of atoms in that are present. So, like sodium, we had 2, carbon, we had 1, oxygen, we had 3, then we added them. Thank you for watching. If you enjoyed this, come back for more.